Hi, good evening. I am Dr. M. Kamakshay. I'm an open source software evangelist and also a full stack software developer, enterprise solutions architect. In this video, I'm going to talk about a peculiar software application which I have developed for um, business management. Teaching learning connected to business management education, and the software name is SATSA. So it means a software application for data science and analytics. Where is it available? You just have to go to my GitHub, one of the GitHub repositories with the name SETSA Advanced. This is basic. The first one, SETSA, is a basic thing where you will be having only data analytics, some few statistical techniques related to data analysis, and then machine learning algorithm. A few machine learning algorithms like supervised, unsupervised kind of. This SETSA Advanced is actually an advanced application where you have so many things, and it is no, it is not extraneous if I say that it is better than SPSS, because SPSS, with all these features, whatever I'm providing this application, it is close to 1 crore, and this is free. So anybody can download from my GitHub repository and install. But you have to install this application as an administrator. So there is a reason, I'll let you know. So where do you get this software? Just go to this, one of the repositories with the name SETSA Advanced. Click on this advanced setup.exe, and here view raw. This is what you have to click, right? So if you click on view raw, so now your download starts, and I just like this is not this doesn't have security certificate, so but it's a good software. Now when you say save or save as, okay, so I'm going to show you. So what is going to happen? You just have to I am trying to save it in downloads. See now it is downloading because I already downloaded it, but if you are downloading first time, it will give you a, you see it is downloading for my very slow internet, 80 MB file, and it will just download within a couple of minutes, but it will give you a warning saying that there is a risk in downloading and installing the software. You just have to use keep something like that. So I'll try to show you. So it's going very fast. I think yeah, it came to end, and so 76 MB of 80 MB is downloaded. So let's wait for that, and I'm expecting a message. Your browser will let you know. Actually that message, yeah, this is what I'm talking about. You see, advanced setup is not commonly downloaded. Make sure you trust. Yeah, you just have to say here, keep, and now show more, keep anyway. So then your download will be finished. So now when you open, so it looks like this. Okay, you just have to right click. I already installed, but I'm just showing it for your purpose. So when you right click, so run as administrator is what you have to do, and after that next. It doesn't take much time. So I already downloaded it, and it is there in my desktop. See here, this is how it looks like. My cursor, you just have to look at my cursor. Now I'm going to open that, and I told you that it should be in administrator mode. Why? Because when you open the software, it try to download. I used a package called the NLTK, so it downloads certain data from online sources, and you have to download and keep it inside this installation directory. It needs administrator privileges. So that these two things you need to take care in order to understand. Once you in order to install the software, once you install, it just opens like this. You have so many things here. The file menu has so many options. You can import open CSV file, text input for NLP. I'm going to talk what is that in a couple of minutes. Then edit, you have just like in SPSS you have record, compute variable, something like that. All those things will be there here. In transformations you have data simulations. You also can create some data, and multivariate normal distributions you can create, and data decompositions you can perform Cholsky decomposition, QR decomposition, SVD decomposition, etc. And standardization is, you can just if you have data in your window, you can standardize that using a number of techniques. In data analysis, you have so many options like, descriptive statistics, inferential statistics, where you can perform t-test, chi-square test, normality test, ANOVA, MANOVA, and everything. And in exploratory, you have correspondence analysis, multidimensional scaling, principal components. In correlation regression, correlation analysis for both, multivariate, bivariate regression, multivariate, bivariate. In factor analysis, you have exploratory factor analysis, confirmatory factor analysis with mediation analysis. I'm going to talk what it is in a couple of, in a couple of videos from now. So this is just an initial, and you can perform cluster analysis. You can use both the k-means clustering, hierarchy clustering, and time series analysis, where you can just do stationarity test, some prerequisites required for time series analysis, and seasonal decomposition, moving averages, whole filters method. So these are all things. And in machine learning, you have logistic regression, decision tree, random forest, naive bayes, k, nearest neighbors, neural networks. And they're supported with all these methods. Not only perform numerical analysis, they also display a few plots required for reporting. I'm just going to explain. And this is NLP which I'm talking, and talking in this video, because this is very essential. SPSS never provides all these menus. So till here it is okay. Data analysis, this first of 5 data transformations and data analysis is being provided in SPSS. But for machine learning, you need to buy a special add-on, or maybe some sort of modules in SPSS, and for every module you have plus X money. With all modules, SPSS is close to 1 crore, but this software is free. So in NLP, you can just upload some text corpus and then convert that into document term matrix, and then you can also extract the features. This is called feature engineering. We talk in machine learning, and there is a provision for meta-analysis, where you can just import a few studies into this application and then perform meta-analysis for various subsets, like analysis like fixed effects, random effects, and a few tests like homogeneity. This is actually a methodology related to meta-analysis, which I will be speaking in one of the videos. And it performs bibliometrics, like analyze basic metrics, keyword analysis, citation analysis, co-authorship network analysis with plots, biometric coupling, word count plot, and last but not least, there is a menu where you can just so I am just going to upload CSV file. So you just have to, I think I have to go to the place where I have kept this data. Where do I have data? Files, yeah. So here I have a data file CSV. So when you upload your data file, these are all. So gender, education, salary, age. Gender, education categorical, family categorical, salary, age, it is actually scale data. It is continuous. SAT 1, it is actually satisfaction 1, a question. This is survey data. So assuming that we have 3 questions, satisfaction is measured in 3 different variables, SAT 1, SAT 2, SAT 3, and attitude is measured in 3 different variables, attitude 1, attitude 2, attitude. These are questions, survey questions. Perception is measured in 3 different variables, per 1, per 2, per 3, and age is actually, this is a simulated data set. I simulated some random data variables, which I will show you later, and this age is again recoded into some scaled variable, some 1, 2, 3, something like that, and the same age 3, 1, 2, 3 recorded again into satisfied. If 3 satisfied, 2 dissatisfied, 1 dissatisfied, something like that. So this is actually survey based data, which I assume that you know some fundamentals of data analysis, because I can't talk everything in this one single video. Maybe I'll be doing a couple of other videos related to analysis, but not for measurement scales or something like that. Now if you want to see what are the different column names, you just have to press show features under edit, then it will show these are the column names. Okay, so you can just also download the report. I don't know which will work or not, because this is actually not a full version, it's a trial version. Yeah, this will not, you need to buy the version, but you can create the outputs. It will Now in the same record and all this I will discuss later, so I will just thoroughly go ahead and show you some sort of analysis. For instance, I would like to do some descriptive analysis, like frequency table. So it will ask you which so I want to do the frequency table for gender, education, and then family. Okay, so this is how outputs look like. So these are the frequency tables, and you have bar chart here. And then let me go to summary statistics. This is for numerical variables, salary, age, and if maybe I take sat one variable which is a measured. Yeah, it will show you a box plot with summary statistics. So salary, mean value for age, mean value for sat1, something like that. And then let me go ahead and so inferential statistics. I would like to do some t statistic, t test. Enter two numerical variables, comma separated. So what I want to do, salary. I want to go for okay sat. I assume that the mean values of satisfaction 1, variable satisfaction 1, and attitude 1 are same. Null hypothesis. If you don't know two sample t-test, you just have to read it. And now, yeah, box plot. If you look at the mean difference seems to be statistically. It doesn't seem to be statistically significant, but it is negative. Okay. So left tail test, and then p-value is greater than 0.05. So at 5% significance level, we don't have evidence in support of the alternative hypothesis. The mean values are same. So here, if you look at the bar plots, though there is some certain difference, but in population, the mean difference is insignificant. Okay, so let us go to some chi-square test. Yeah, of course, I like it a lot. Gender versus education. I want to make a cross tab and perform chi-square analysis. Yeah. So what is the chi-square statistic? 2.5 and p-value is 0.28, and we don't have evidence in support of our claim that they are actually dependent. So these two variables, age and what I took, I think gender and education. Education does not depend on gender, so they are more or less same. They are independent. So we cannot take decisions of education related decisions based on gender, vice versa, something like that. Now let us go to other parts of there are normality tests in case if you want to. I wanted to know if the salary is normally distributed or not. Then here there is some analysis like p-value is there is Shapiro-Wilk statistic, Shapiro-Wilk p-value, Kolmogorov-Spino statistic. Okay, now if you look at Shapiro-Wilk test, it says that at 5% significance level, yes, it is normally distributed, but Kolmogorov-Spino test shows that it is not normal. I don't know what is the difference. Okay, that is for study. Now go to the ANOVA. Yes, right. Let us look at the enter numeric dependent variable and categorical independent variable. So numeric dependent variable, I assume that satisfaction depends on gender. Okay. Now yes, p-value is not produced. I think there is something went wrong, but plot is being produced. So I think the variables, there is something went wrong. I should not perform. Let us change the. Let me change the ANOVA. I take salary this time, and then it depends on gender. I assume that gender is independent and salary depends on gender. So intergender differences are statistically significant. That is alternative hypothesis. Now, yes, this time you got so my assumption is correct this time. So p-value is greater than 0.05, 5% significance level. We fail to reject the null hypothesis that the mean values are equal. That intergender level means for salary are in fact equal, something like that. Okay, so this is ANOVA. Next, let me go to some sort of MANOVA. Yeah, of course, it is a heavy technique. Let me do it, but I'll skip. Okay, I'll do it. So dependent variables. So what are the different dependent variables? Sat1, attitude 1, perception 1 depends on what? Let me assume gender. I think I should not take categorical here. Let me assume um, age. So age level differences to satisfaction, age level. Yeah. So there is some certain output which I am not going to say here. There are estimates, Vex, lambda, Pillai trace, and all. So these are estimates and corresponding p-values are here. These are the p-values. All of them are significant. All of them are significant. Okay, this is for age. So intercept is significant here. You see, look at the if I look at the Vex lambda, p-value is less than 0.05, so at 5% significance level, I do have evidence in my hand to state that the fixed effect is significant. And then for statistic, say here again there will Wilks lambda repeats here, which is not significant. So overall, age failed to explain our dependent variables significantly. So that is what, if you don't if you don't know how to understand this output, just take this and paste it in ChatGPT. It will let you know. It will give you a lot of interpretation. Now let me go to, so you can do correspondence analysis, multidimensional scaling principles. I'll take some other, I'll make one more video to talk about correlations, regressions, factor analysis, exploratory, confirmatory, cluster analysis, time series. So I cannot explain all these things within a video. In this video, so I have shown you how to perform some, petty, small statistical analysis like, descriptive statistics, inferential, exploratory. So now what I do is I'm interested in testing a model, okay, that using NLP, natural language programming. So how am I going to do? So I have some certain data set in my computer. Let me open files. So I'll take you to, I have a set of abstracts that are downloaded from Scopus. If you don't know what is Scopus, I'm extremely sorry. So this is my Scopus dataset, Scopus copy. So it is actually a world-renowned popular repository where most of the research articles, abstracts are available. So I have downloaded how many? There are 30. I think this last one is not no abstract. I'm going to delete it. That row. Yeah. Now I have 29 abstracts. What I'm going to do is that this abstracts belongs to a particular such phrase called the impact of, I don't know exactly what is this, but I think neuromarketing, something, this text corpus is related to neuromarketing. I can even show you, okay, I'll show you how to download the data because I have low bandwidth, and so instead of just confusing you, don't say, okay, good. Now I'll take you to Scopus now, so all of you. So here, Scopus, as I said, it is world-renowned popular repository for database for abstracts. Where is the search? This is the author profile. Can I go to author search? It is not author search, I guess. No. Yeah, guys. So I'm finally. Yeah, guys. So I'm finally actually. I have logged in using my institutional ID. So I just have to go to my university ID and then use login credentials, and then logged into Scopus. And here, this is what I'm trying to talk. So I'm going to search something called marketing, and maybe new row. No, not new row market. So I just wanted to know what are the different trends, ideas, um, in the neuromarketing field. So there are 1,307. No, that is not um, neuromarketing strategies. Strategies. Yeah, 234 this time. Neuromarketing strategies and let me say consumer trends, something like that. Okay. I'm just trying to struggle. 22 documents. Okay, fine, good. So I'm trying to minimize the number of documents for my search. So now go to exports, CSV. I just need abstracts. So what I do is just select abstracts and export. Now I'll get the file. So let me take you to save as. I'll just go to downloads, neuro mark. Okay. So now my objective is that I just would like to look into the various ideas, concepts, the trends that are going on in neuromarketing related. And remember, my query is neuromarketing strategies, consumer behavior, something like that. So I am assuming that this consumer behavior, neuromarketing is interrelated. So that is what is my thought process. Now, if I open that file, I'm just trying to show you how to obtain the data file for natural language processing. The whole idea is being, I'm going to delete this. I don't want the first column. They are just no links. I just need the pure abstracts. Yes. Now I don't want this first row also. Yeah. This is a pure text corpus. Abstracts. Now what I do, this is a CSV file. I don't need to worry about this. Now close this. Go back to my application. Where is my application? This one, right? So go to file, go to text import, and here import data file, and I have to go to downloads. I guess I downloaded to downloads. Yeah, neuromarketing. Now it shows 21 rows, and with one column is being imported into the application, right? Now straight away go to the NLP. I wanted to convert that text corpus into document matrix. If you don't know what is the document matrix, I'm extremely sorry. You need little exposure for natural language. If you are watching this video, I'm sure you are in requirement of some NLP kind of activity, and your interest is to find out the few potential ideas in the existing body of literature connected to a particular such a phrase, just like what I have shown you. Now DTM. So where is the column? What is the column indexed where you have the abstracts? This is 0 because it's a Python application. Python is 0-based index language, and I have kept my abstracts in the very first column whose index is 0, something like that. Yes. Okay. Now it is asking you how many top words. So here our assumption is that each word represents an idea. It is called term vector, word vector, something like that. In NLP, term vector refers to an idea in that current field. So if you type all, so all the ideas will be retrieved into your window, but I don't want to populate all unnecessary things. I just want top 10 ideas in that text corpus. Yes, of course. Now I got some variables. Go to edit and show features. Now these are the top 10 ideas in the current text corpus. So let us look at them. Behavior, consumer, so consumer behavior, marketing, data, marketing research, and social research, and social data, something like that. You see. Now if I look at this, you know, I perceive or I observe there are two factors here. That is, I can classify these columns into some consumer behavior and marketing research or marketing data. So I can assume that consumer behavior might depend on marketing research, but I'm not convinced with that thought. So let me just go back and then go to the NLP and then DTM, this time 0, and this time I want 50. So let me go ahead with so go edit and then show features. Yeah, this time I have behavior, chapter, consumer data, marketing, quantum, research, social study used. Still not, but behavior, consumer behavior is okay for me. And then marketing data, how can I assume relationship? Mm, marketing research, no. So let me go back. Um, sorry, DTM, and then this time again I'll go for 20. Let's see, what does that look like? So good. AI, this time something appeared AI, it's quite interesting. Now show features. I got AI, analysis, behavior, brain, consumer, data, future, marketing, quantum, research, socials, something like that. Now I got some sort of brain and AI. Is looks to be a bit convincing. So I can assume that there are two factors here: consumer behavior and then marketing research, and then AI and brain. So that is, or I can just go across the brain behavior, um, consumer behavior, brain, something like AI data analysis, that I can assume. So AI data analysis into one dimension, consumer behavior into one dimension, and what marketing research as one dimension. So there are three dimensions. Let us assume that these three dimensions is valid for my analysis. Now what? So how can I assume? So now that I got some data here, so let me go to data analysis, and there is something factor analysis which I have spoken just. I'll go to confirmatory factor analysis. So how many factors I'm assuming? I'm assuming three factors. Now what are the variables for first factor? Let me go back to that diagram. So I'm sorry, this is very old. So E, show features, yes. Now let me go to data analysis, factor confirmatory. Now three factors. Now the first factor is going to be um, so something T, okay, and then technology AI. I would like to define technology with AI, data analysis, some technical dimension, something like that. And now enough. Then maybe you can say something else. Okay, now I want to go for factor 2, and it is going to be behavior. Here I would like to consider consumer behavior, and then what? Brain? Don't know. Okay, and third factor is going to be some marketing aspect, and that I would like to marketing, and then research. Maybe I can also take data, which I already considered in some other factor. Marketing research, data analysis. I'd like to. Now, how are we going to assume the relations? Now, the relations behavior, consumer behavior, depends on technology, which is mediated by marketing research, something like that. So, consumer behavior depends on technology, and now the marketing mediates, right? So, consumer behavior, marketing explains consumer behavior. So it is like technology, marketing, and behavior. So technology influences, yeah, and now behavior again depends on what? Left side, marketing. sorry, technology. So behavior, technology, marketing. That is actually triangle. So marketing mediates technology and behavior. Behavior is influenced by technology, something like that. Okay. Now this is the analysis. Now when you look at this, you see interrelationships. So there are certain arrows. Technology leads to behavior, and this marketing. So we have forgot one arrow between technology and marketing. That is why it is not. But anyway, it's okay, fine. So marketing is being explained by marketing, research, analysis, data. Now technology is also explained by, you see the arrows. So arrows, by the direction of the arrows we can, now looking at this, the effect for technology versus behavior depends on technology. That is not statistically significant. And marketing research, data analysis also influences behavior. That is also not statistically significant. So those ideas are not statistically significant in the text corpus. Now AI influences technology. Of course, this is actually a constant. Let us not look into data. So these are all manifest variables. These are all. So we can. I don't find any. Yes, there is something behavior significantly. This is actually a manifest variable which explains a factor B. It explains significantly because p value is 0 to 0.004, which is less than 0.05. 5% significance level, it is statistically significant, and rest of the relationships I don't find any significance. So the ideas, the model which we would like to test here, that is technology influence behavior and the marketing mediates behavior and technology. This model doesn't exist in the current body of literature. So the current ideas may not support these assumptions and this theory. Maybe if we change the search strategy and increase the literature, the abstracts, maybe we may be able to find some significant effects. It depends on various aspects. Like I can change my query in Scopus, and I can also change the definitions, like which factor is explained by which variables. If I adjust those manifest variables to a given factor, also I can find. So this is just a kind of demo video where I would like to explain you how to make use of natural language programming through this video in order to test your models with given few assumptions, basic assumptions, with the help of confirmatory factor analysis, something like that. So thanks for watching this video. Stay tuned for the new content. In my next videos I'm going to touch on different other analysis available in this application. Bye bye for now.